Welcome to Coffee and Conversation. I'm Honorine, and today I'm with Stacy Ashlyn, who is doing a PhD in mechanical engineering. Welcome, Stacy, to Coffee and Conversation. Thank you for taking the time of doing this interview. Can you tell me more about who you are? And let's start with who you are.
Yeah, I'm a mechanical engineering PhD student. And I'm focusing on dynamics and controls, which is more specific to robotics, essentially. I came to FSU because I was interested in a lot of the research going on. So FSU has a very big biomath department, which I took a lot of courses in that department. So I learned a lot about mathematical modeling of biological systems. And I was also interested in a lot of the work at FSU in robotics and prosthetics and those types of things. So that's what landed me here. I'm originally from Philadelphia.
Okay, and so FSU has a strong department. Is it a famous department?
Yeah, FSU's Biomathematics Department is honestly one of the best in my opinion, and they do have a lot of recognition, and they're definitely centered around things that you can't find at other schools. So that mathematical modeling, a lot of schools do like things more like biostatistics and statistical analysis, things like that. In relation to biology, FSU is a lot more model centric, which was really interesting to me because I was interested in engineering and biomedical engineering and kind of understanding how to get things developed faster. And a big part of that is simulating things because testing takes a lot longer to do. So you want to be able to simulate things on a computer, but if you don't know how to model the things through like mathematics and physics, then you can't make a simulation, and then you have to do what could be years of testing that you could get out in like a week or even a day on a computer.
Oh, wow. Technology. So your research focuses on penguin.
Yes.
So can you talk more about that?
So I'm trying to understand a big problem in robotics and also exoskeletons, which is kind of an area of interest for me, is stability and also energy efficiency. Penguins are frequently on ice. Emperor penguins spend extremely long periods of time walking across these like slippery surfaces. Also, studies have shown that penguins are like one of the most energy efficient bipedal walkers. Robots have limited battery supply. So just like your phone, you have to charge it all the time. Robotics, you have to charge them. So you kind of don't want, if someone's using a robot as an assistive device, like it moves their legs for them if they're paraplegic and they're relying on it in that way, you don't want them to have to charge their legs constantly. So you want to figure out ways to kind of capture that energy efficiency that's a lot more common in biology, and that we haven't been able to reach the same level of energy efficiency in robotics that, for instance, humans have reached. Mm-hmm. So I'm kind of trying to understand how energy efficiency is achieved in biological subjects. And I chose penguins as my biological subject because of intrinsic properties of stability, that they have a lower center of mass, and they keep, when they waddle, they keep their supporting structure over their leg. Where like when we walk, we like keep falling forward. So it's easier for us to slip because we like don't have that supporting structure right underneath us, where penguins take smaller steps. So intrinsically, they're just more stable, which I thought was a really interesting concept to try to bring into engineering.
And how did you come up with the idea of studying penguins?
There's a lot of work done in bio-inspired robotics, also biomimetics, which is slightly different. Bio-inspired is trying to like come up with the ideas behind why things work the way they do and kind of translate them, where biomimetics is more trying to like copy a specific gait and things like that. So they're like kind of related, but a little bit different. And there's a lot of studies that have been bio-inspired. So for instance, there's climbing robots that were inspired by geckos. Geckos have like little hooks on the bottom of their feet, and they put little hooks on robots, and the robots are able to climb up walls. You can see that in the robotics lab at FSU. We have robots in our open house. You can race climbing robots. So you can have a lot of fun with climbing robots. We build them, we have them. It's cool. We also have a Cassie robot. And Cassie, kind of the scientists that were working on that, one of which is Dr. Hibiki that works at FSU, they looked at bird locomotion and got some inspiration from bird locomotion. And Cassie's design ends up being very similar to like an ostrich type of legs. So she's a big bipedal robot, and they were trying to get information about energy efficiency from guinea fowls. So that's where it started off. And yeah, so I talked to Dr. Hubicki about his work with guinea fowls and about introducing stability. And I said, well, if I'm gonna do slippery surfaces with a bird, I'd like that bird to be a penguin, because I'd like the bird to know the slippery surfaces and be, you know, an expert on approaching these, because I don't want to base it off a bird that, you know, is going to fall over, because then the robot's going to fall over.
That makes sense. So are you in contact with like actual penguin?
Yeah, so I have an ongoing collaboration with Moody Gardens Aquarium, which is an aquarium. It's a nonprofit aquarium in Texas, and they have a huge variety of penguins. They have over 100 penguins, and they have over 6 species of penguins. I researched a lot of aquariums before choosing who to collaborate with, and I'll tell you, like Moody Gardens, yeah, they have a good history of having very good relationships with their animals. So it seems, so I really trust the workers there, and I trust that they really care about their animals and they take care of the animals, because the animals tend to be very easy to work with in studies. And Moody Gardens definitely has a huge variety of species that most other aquariums don't have. A big problem for my research is most aquariums have warm weather penguins, because it's a lot more feasible. It's harder to make a cold climate atmosphere for the penguins to live in. So a lot of aquariums have things like African penguins or Humboldt penguins that are like typically found on like sandy beaches, but I wanted penguins that were found on ice. Mm-hmm. So I searched around for quite a while, and I've been really happy to be working with Moody Gardens Aquarium. It's definitely like a fun time. I haven't gotten to go out there yet because of COVID, but it's on the horizon. Hopefully at the end of the summer, I'll start collecting data with the penguins.
So how does it work exactly? Because I work with books, so you know, it's very different. Are you supposed to go to the aquarium and stay there for months studying the penguin, or how does it work?
So in general, the first thing would just be to get a pilot study done. So that would be a shorter study, probably like a week, where you just get the information and you'd see how it goes. And then you'd kind of go back and look at all the data that you collected and figure out what it all means and see if there's any problems with your experimental design. And then after that, you would go back, preferably for a longer period of time, but it really depends on the aquarium and the availability. Because yeah, I mean, the aquarium has to have staff oversee you. So does it cost to an aquarium. It is a big deal to have that collaboration, and I'm very appreciative. So yeah, we're definitely starting out with a pilot study, and we'll definitely have a second study after that. And in terms of timelines, that's something that, you know, really needs to be figured out with the aquarium, of what's doable and what's not doable. Some of that has to deal with when I'm available and when they're available and when the penguins are available, because there's a lot of complications, right? I mean, aquariums have busier seasons and less busy seasons. So there's that. And there's also penguins have lives, and they don't necessarily want you bothering them when they're raising chicks, right? And hatching eggs. The other thing is that penguins molt. So they like, so the way penguins have like a giant coat of feathers, right? Uh-huh. And every year they like lose all of their feathers and they grow new ones. But in that process, they like don't lose their feathers until all the feathers underneath have grown in. So penguins are kind of grumpy and itchy and upset during this molting period. Okay. Each species of penguins molts at a different time. Oh, to make things. So, and they also breed at different times. So I'm working to figure out what species makes sense for the studies, what one. There's complications with that, right? There's there's minimum weight requirements, maximum weight requirements. Each penguin's a different weight, each species. So there's like a lot. It's not trivial to just go and start working with penguins. There's a lot of like very complicated considerations that have to be worked out. Okay, and so you were talking about experimental design. So does it mean that you bring your robot there? I am interested in experimental design and the relationship between penguins and robotics. That's something that I'm interested in addressing, because essentially some things would be easier and more accurate if you introduced robotics into it. So one thing is motivation, and it's a little bit complicated because typically in biomechanics studies, people are involved in the experiment. So people are like putting little treats in front of the animal, or kind of like, you know, encouraging the animal behind it, clapping or something along those lines. But then you have variability do to the person. It's a less controlled study. So I am interested in trying to get robotic devices to kind of do those motivations.
Okay.
And that's something I am considering in terms of robotics in the actual experiment. In terms of like Cassie will not be around the penguins. Cassie, the hope is that the robot will walk like a penguin. So the hope is essentially to figure out modifications to make to a robot, to a bipedal robot that can match the weight distributions of the penguin and then take all the penguin data and turn that into a control system and put it on a bipedal robot.
And so basically to pretend that it's a real one to see how it reacts and all that stuff.
So one thing, Cassie robots, Agility Robotics, that's the company that makes them. They just made a digit and they have it like delivering packages, for instance. So it's like, okay, if it was like an icy day, then you might want to have like a mode in the robot that it could start waddling if it sees an icy patch so that it can maintain stability. So those are kind of the concepts of just being able to have gaits that we know are stable and energy efficient on robots.
Okay.
It's kind of the goal.
Okay. Wow, that's fascinating. So besides research, because as graduate students, we also have a life. So you were just telling me earlier that this semester has been long and you have 3 classes of coding. So you basically spend all your time in front of your computer. What do you do that is not on the computer? Because, you know, everything is on the computer now, Netflix or all that stuff. It's always about a screen. So do you try to find time away from the computer, away from screens in general?
So before the pandemic, I was on FSU's water polo team. So that was a lot of fun. And I can say that my workouts do not compare and they are not nearly as fun. And they don't keep me in as nearly of good of shape as the water polo workouts did. But since then I've been doing runs, which is kind of uncommon. You know, I like to do like kind of Zumba and online stuff, but because of the pandemic and I'm in front of a screen so much, I do take the time to go outside and go for runs and bike rides and try to spend some time outdoors. It's been hard to balance and to get away from the screen. I think the hardest part was really just when the pandemic hit for me.
Okay. Because
that was my first semester. I had just transferred into the mechanical engineering program. So like, I didn't really get a chance to make friends. Like my transfer into the mechanical engineering department was that I decided I was going to get a mechanical engineering PhD without ever taking a mechanical engineering class in my entire life. And I worked with my advisor and we signed me up for all PhD level classes. And I didn't have any of the prerequisites for any of the classes. So winter break, I tried to catch up on like 5 years of engineering. And then spring came and classes were hard. I mean, I did a big jump. And then the pandemic hit and I hadn't gotten people's numbers, you know, like, I mean, like I could ask them questions like about the homeworks, like when I saw them, but I didn't like form that close of friendships before the pandemic hit. So I was struggling that first semester because I wasn't an engineer, right? And I wasn't around engineers.
Yeah. So when you said you transferred, where did you transfer from?
So I was originally a biomath PhD student and I decided to switch to engineering because I was interested in robotics and kind of doing a little bit more hands-on work and doing work that related a little bit more closely to engineering because I see myself ending up in like an engineering company post-graduation. Okay,
and so that was an FSU transfer basically.
Mm-hmm.
So that was a good thing, but then the pandemic hit and that was too much work.
Yeah, and honestly, it was really that spring semester and I was so overwhelmed and so upset. And then by the time fall semester hit, I was pretty good because I worked on research the entire summer. So like a lot of the skills that I didn't have, I spent a lot of time and I had an entire summer to build those skills up. Yeah. So by fall semester, things were a lot easier. And then by spring semester, despite the fact that everything's been online, I managed to connect with people through Zoom and through like a Slack channel that my research team has. So so at this point, like I have friends, which was something that was a big fear of mine spring semester was like, okay, well, like, how am I going to make friends with like classmates? So I have people to work with for group projects and things like that.
Yeah, no, I came up to a new program and I was the only one in my cohort. And my first year was really hard because I came from Arizona, and coming to a new program where you don't know anyone is hard. And it was hard for me being face-to-face, so I cannot imagine what it was to be online.
Yeah, I've made connections. I've gotten pretty close with a couple of my classmates, and I started working as a supervisor for undergraduates. FSU has an undergraduate research opportunities program, UROP. And I signed up to be a supervisor for that. So, and that's been going really well. I mean, I have like really bright students working underneath me, and I'm really proud to be part of that.
Oh, that's amazing. Before coming to FSU, what were you doing?
So I was undergrad. I did applied in computational mathematics. That was the degree I got in undergrad. And I was working as a research assistant for like 3 years by the time I graduated. I had been doing like internships in engineering and stuff on the side because, like I said, I was really interested in kind of mathematical modeling in applying it to engineering. So I got like a physics minor in undergrad, and I did some work in like electrochemical engineering, and I also did some work in like manufacturing engineering type stuff. So engineering was kind of around, but I was definitely mostly math focused. I mean, I was presenting at math conferences and things like that and winning math awards in undergrad.
Oh, nice. What does your ideal future look like?
Years ago, right? When I was just starting out, my freshman year, I had a friend. He got a job working on a product from Liftware where he made spoons that could balance for people with Parkinson's. And that was just an amazing thing to me. It was just amazing that like you could develop something that seems like relatively simple, but like literally impacts people like every single day. So I thought it was really inspiring to see how engineering could be life-changing. And that's definitely where I want to end up in the future, is kind of trying to help the disabled community by creating engineering devices that contribute to probably everyday living, perhaps rehabilitation as well. That's generally the goal of where I want to end up. I think it would be a really fulfilling career to be able to work on devices like that.
Yeah, definitely meaningful. Do you have an ideal device?
I think like prosthetics, exoskeletons, rehabilitation devices that are like help people walk again. Mm-hmm. Those things are really cool. I'm pretty open to different fields. I'm really happy with where I am. And I think that's what's important. And I'm excited about options I'll have in the future.
Well, I think that's a great way to end this interview. A message of hope. Well, thank you so much for taking the time for me to interview you. And I wish you good luck with the end of the semester.
Thank you.